in this video, I'll be teaching you guys how to do proofs by counterexample. And you'll realize that this is probably the easiest proof method. So when you see this proof on your exam, you should be very happy because this is basically a free point. And I'll show you why by doing these 3 examples throughout this video. So I'll explain all of them step by step. Let's move on to the first problem. So the first proof we're going to do is for every pair x, y, x plus y squared is equal to x squared plus y squared. Now, this is a claim that takes every pair. So remember, every instance of x, y, not only one, but every instance of x, y must hold true with this equality. Here's the thing. We're going to counter this. So we're going to say this is not true. This is not a true claim. And we can do this by just providing a singular example of this guy being wrong. Let's go ahead and write down, doesn't really matter which one you pick. I'll write down, consider 3, 2. All right, consider 3, 2. When x equals 3 and y is equal to 2, we get 3 plus 2 squared is equal to 3 squared plus 2 squared. And we can turn this into 5 squared, which is 25. And we can do 3 squared, 9 plus 4. All right, 9 plus 4 is 13. So we have 13 on the right side. Here's the thing. This statement is false, right? 25 and 13 are not equivalent, okay? Since 25 and 13 are not equal, the claim is false. All right, that's really all you need to put down. It's a very short. It's very short compared to direct proofs and proofs by contrapositives, like the previous videos I've covered. But this guy, very easy. Remember, when you ever make a claim, whenever you see a claim that states for every or for arbitrary, okay, and it's false, you just simply need to provide one example of this claim being wrong for the entire thing to be wrong, right? If I tell you that every single outlet will shock you, okay, you know what? Okay, every single outlet can probably shock you, okay? Never mind. Do not touch outlets. But if I told you, for example, all pencils can write, and then I give you a pencil without graphite, okay, then I guess not all pencils can write. You know, that statement was false. So that's the logic behind proof by counterexamples. Let's move on to the next problem. Let's take a look at this problem. For every integer n squared plus n plus 41 is prime. Let's go ahead and think of a counterexample. A matter of fact, there is one. Now, here's the thing. Don't expect to see this problem on an exam because it's very tedious to solve. But consider n is equal to 40. Okay. N is equal to 40. A matter of fact, it's actually the smallest number n for where this works. So that's why I said do not expect to see this on an exam, because how are you supposed to know that this is the answer? Okay? Well, now that you know this, let's go ahead and plug it in. So let's get 40 squared. So wait, let's write down plugging this in. So plugging in n is equal to 40. We get 40 squared plus 40 plus 41, which is equal to 1681. Okay, here's the thing about 1681. 1681 is equal to 41 squared. All right, try to test this out in your calculator, which means when n is equal to 40, n squared plus n plus 41 is not prime. And we could say, I don't know, end this differently. You can write down multiple different things. I don't know. Let's say, therefore, not for every int n is n squared plus n plus 41 prime. All right. This is a way you can write it. Now, you don't have to write down consider. You can say, let's say n is equal to 40. Okay, you could, if you want to write down let's say. I write consider because my professor uses consider. And you can also conclude this in different ways. So keep in mind, do not follow my exact format when you're writing down proofs. Maybe you can learn how to figure out your style. What are you more comfortable with? What language are you more comfortable with when you're writing your proofs? But that's enough talking. Let's move on to the next problem. Let's move on to the last proof by counterexample. This one is quite fast. Let's write down consider. Let's consider a is equal to 4 and b is equal to 2. Okay? Which means 4 is divisible by b squared, which means 4 is divisible by 2 squared, which means 4 is divisible by 4. And obviously, this is true. Okay? And this is true. And keep in mind, sometimes I write extra when I'm doing my proofs. I try to be extra clear, especially for the graders. But most of the time, people understand. Just try not to be too vague in your language, and like using logic without stating it, where you got that logic from. But in the previous proofs that I did in this video, I definitely wrote extra or more than I had to, but that's completely fine. Remember, it's just up to your proof style. What am I even talking about? I should get back to the problem. I didn't shut up. But we could just consider the last case, A, B. So let's write down 4 and 2. Does 4 divide 2? It does not, right? 4 does not divide 2. This is our statement. Therefore, and I could write down some conclusion. I could just restate the previous statement, or I could just leave. I think my teacher doesn't even care. I could just leave it at this. This already disproves it. But we could write down therefore for all ints a b for not all ints a b, if a is divisible by b squared, then a is divisible, then b is divisible by a. What am I saying? A divides b squared and a divides b. Okay, I keep saying divisible in the wrong order. But anyways, this is it for the video. Remember, proofs by counterexamples. If you see a statement that makes an absolute claim, like every, all, arbitrary, right, using those keywords, then usually, if you want to disprove it, you need to simply make a case which is just, wait, what am I thinking about? You need to think of a single case in which that statement is wrong, therefore the entire statement is wrong. Remember that. And that's the whole point of proof by counterexample. But anyways, if you have any questions, put it in the comment section. And if you found this video helpful, consider subscribing and liking the video. I'm going to attend my online lecture.